Hey guys, Mr. Tracy here. Unit 10-8 is going to be using zeros to find solutions of polynomials. As you can see, this is actually the last unit the last lesson in Unit 10. So after you guys do the assignment for this one and turn it in, we'll have a castle learning on stuff from this unit. That'll be like your assessment for this unit, and that'll be due at some point next week. So let's get started. Using zeros to find solutions of polynomials. All right. So this says if p of 7 equals 0, then 0 is a. Then 7 is a. I kind of just gave it away. Well, if x is 7, and when I plug 7 into some function, I get 0, that means 7 is a 0, or a root, or a solution, any one of those, or an x-intercept, okay? Any one of those things, okay? So what does that mean? We learned this in the last unit. If p of 7 is 0, that means that something is a factor of p of x. Well, it's actually the opposite of positive 7. It would be, which binomial is a factor of the function p of x? Well, it would be the opposite, so it would be x minus 7. That means if I divide whatever p of x is, it's some function, okay? When I divide this p of x by x minus 7, okay, I'm going to get some sort of a quotient without a remainder. Okay. Similarly, down here, if x plus 4 is a factor of p of x, then something is a 0. Well, if x plus 4 is a factor, what number do I know for a fact is a 0? Look up here. No, it would be the opposite of this number, would be the 0. So that means negative 4 is one of the solutions, or one of the roots, or one of the zeros of that equation. Okay? Negative 4 is the 0 of p of x, and p of this number here, what does that mean? That means when I plug in negative 4 into the function, whatever it is, p of x, what should I get as my output, or my y value? Well, if negative 4 is an x-intercept, when I plug in negative 4 into the function, what's going to be my y? 0. Alright, let's use some of that information to solve some problems, and we'll use these solutions, or these zeros, to find the other solutions of the polynomial. Let's take a look at number 1. Given that x minus 4 is a factor of the function 2x to the third minus 5x squared minus 11x minus 4, algebraically find all of the zeros. Alright, well, just a little quiz. X minus 4. If x minus 4 is a factor, do I know one of the zeros right off the bat? I'll go back to up here. Okay. If x plus 4 was a factor, that means negative 4 is a 0. If x minus 4 is a factor, what's definitely one of the zeros of this function over here? Probably positive 4. Alright? Well, not probably. Definitely positive 4. Alright? Now, I want to use this information here, given that x minus 4 is a factor of this function, to find the rest of the zeros. Okay, so I have to find the other factor. Like, what can I multiply x minus 4 times something to get this function over here? Well, the way that I would find the other factor would be to divide. I'm going to take this function over here, divide it by x minus 4, and that's going to give me the other factor of the function f of x. Alright, so we're going to divide. We'll do that over here. X minus 4, division sign, 2x to the third minus 5x squared minus 11x minus 4. All right. Okay, so first step is I always take a look at this term right here, and I say to myself, okay, what can I multiply x by in order to get 2x to the third? I'm pretty sure it would be 2x squared, right? 2x squared times x would be 2x to the third. That's good. All right. Now we have to take this number and multiply it by the other term. 2x squared times negative 4 would be negative 8x squared, right? Okay. Now, remember, just like long division that you learned in elementary school, okay, we're subtracting this from this up here, okay? We're subtracting this binomial from this binomial. So we're doing 2x to the third minus 2x to the third, which cancels. That's good. And I'm doing negative 5x squared minus negative 8x squared. So remember, minus and negative is really plus. So I'm doing negative 5x squared plus 8x squared, which is 3x squared. What's my next step? Take this guy, negative 11, negative 11x, and bring it down. Now we go back up here, okay? We take a look at 3x squared and we say to ourselves, okay, my next term over here in my quotient is going to be whatever I can multiply x by in order to get 3x squared. So what can I multiply x by to get 3x squared? How about 3x, right? A positive 3x. 3x times x would be 3x squared. Awesome. And then we just multiply this times this, 3x times negative 4, and I get negative 12x. Okay, remember I'm subtracting this whole thing, so it's 3x squared minus 3x squared cancels. Negative 11x minus negative 12x, that's really plus 12x, which is just x. Bring down this guy, negative 4. Okay. Now, what am I multiplying x by in order to get x? 1. 1 times x is just x. 1 times negative 4 is negative 4. And what's going to happen here when I subtract this out? X minus x is 0. Negative 4 minus negative 4 is 0. Okay? So, what does this mean? It means there's no remainder because we're done. Okay, we're not left with anything down here. As soon as I get to 0 and we're out of terms, that means there's no remainder, which is good. This means that x minus 4 times 2x squared plus 3x plus 1 equals this polynomial here. Okay, that means these two are factors of this. Meaning, if I took x minus 4, the divisor, and I multiplied it by the quotient, 2x squared plus 3x plus 1, I would definitely get what's underneath the division sign. Okay? But I'm being asked to find all the zeros. Well, once I have the two factors, what can I do with these two factors in order to find all the zeros? I'm going to set them equal to 0. Okay? Now, x minus 4 is fully simplified. Okay? We talked about it before. I know that one of the zeros is going to be positive 4. Okay? But what about this one over here? Can I break this down any more and factor it? Well, I don't know. Let's see. Okay? There's a 2 out in front, which means I can't just use AM. I have to use AC. So remember, when I do AC, I have to take the first term and multiply it by the last term. Okay, so A times C is 2. All right, so I need factors of 2 that add up to 3. And remember, I'm going to break this 3x up into what? Is there factors of 2 that add up to 3? I think so. Okay, I could break this into 2x squared. How about 2 times 1? What if I broke this into a 2x plus 1x plus 1? Right? Because if I combine like terms, I get this. So I'm just breaking this 3x into 2x and a 1x, because look what happens now. Remember, after you break them up, we're going to factor by grouping. Okay, we're looking for a GCF in both groups. Looks like I could factor out a 2x here, and I would be left with x plus 1. The only thing these two have in common is a 1. And what do I get when I factor that out? I get x plus 1. That's good that these two match. Okay. So what does this break down to? Remember, I take these two GCFs, I put them together, and whatever the repeating factor is, and we're done factoring. Don't forget about this factor up here though too. Okay, I'm just going to bring this down, and I'm going to bring this 0 down, because that's ultimately what we're doing, was finding the zeros. All right, so this times this gives us our original function that we were dealing with. Now in order to find the zeros, I take each factor and do what with them? Set each one equal to 0. All right, so what's this one going to become? Well, we talked about this before. We knew that x equals 4 was going to be a 0. Over here, two-step equation, I would minus 1. Okay, so I get x equals -1/2 is a 0. And then if I subtract 1, I get x equals -1. So x equals 4, x equals -1/2, x equals -1. Those are all of my zeros for this function. Where's my calculator? So just a quick little side note. All right. If I plug in, what does that mean? If x equals 4, x equals -1/2, and x equals -1 are all zeros, that means that this function up here, if I were to graph it, what should be going on at 4, -1/2, and -1? Those should be my x-intercepts, right? Let's just double check that to make sure that we are in good shape. 2x to the third minus 5x squared minus 11x minus 4. And if I were to graph that, looks like I have, okay, so my scale is a little off. I don't want to waste too much time on this. Ooh, my screen is really dirty. It looks like that it touches at -1, it touches at -1/2, and it also crosses the x-axis at 4. We can definitely double check that by looking at our table. When x is 4, I have a 0. When x is -1, I have a 0. And if I changed my table set, I would see that when x equals -1/2, I also have a 0. All right. All right. Any questions? Beautiful. Moving on. Exercise number 2. Given -2 is a 0 of the function 6x to the third plus 11x squared minus 17x minus 30. Algebraically find the remaining zeros. So they're giving us one of the zeros, okay? They're giving us that -2 is a 0. I'm going to hop back up to the top real quick, okay? Remember, sorry, I'm jumping back and forth. Had a lot of coffee this morning. -2 is 0. That means if I were to plug in -2 in for x here, I get 0 as my output. G of -2 would be 0 because it's a 0. All right. Jump back up to the top and think back to our last lesson. If P of 7 equals 0, then what was a factor if P of 7 equals 0? Well, that means that the one of the factors of that function was x minus 7. So if g of -2 is 0, what would be a factor of g of x? Well, it'd be the opposite, right, of negative 2. That means that x plus 2 is a factor. Okay? So, what does that mean? That means if I divide this function here, g of x, by x plus 2, then the quotient will be the other factor. X plus 2 times the quotient would give me g of x. So if I need to find all the zeros, first I need the other factor. What would the other factor other than x plus 2 be? So I'm going to divide this function by this factor, and that's going to give me, just like up here, the other factor. All right, so we'll take x plus 2. We're going to divide that into 6x to the third plus 11x squared minus 17x minus 30. All right, so first things first, what can I multiply x by to get 6x to the third? I think that would be 6x squared, and then 6x squared times x, 6x to the third. Now I got to take 6x squared, multiply it by the other term. 6x squared times 2 is 12x squared. And then remember, we're subtracting the entire thing. 6x to the third minus 6x to the third cancels. Beautiful. 11x squared minus 12x squared would be negative 1x squared. Then we're going to bring down our negative 17x minus 17x. All right. Now, jump back to the top. What's our next term going to be in the quotient? Well, we got to figure out what times x is going to give me negative x squared, or negative 1x squared. I think it's going to be negative x. Negative x times x is negative 1x squared. And negative x times 2 would be negative 2x. All right? Remember, we're subtracting here. Negative 1x squared minus negative 1x squared cancels. Negative 17x minus negative 2x. Remember, that's negative 17x plus 2x. Minus and negative is really plus. So that would be negative 15x? Yeah. Bring down our negative 30. All right. Now jump back up to the top. Our next term is going to be whatever times x gives me negative 15x, which I think is negative 15. Negative 15 times x is negative 15x. Negative 15 times 2 is negative 30, and this is a good thing. Negative 15x minus negative 15x cancels. Negative 30 minus negative 30 cancels, and I'm left with 0. That's a good thing. Okay, that means that we do not have a remainder. Okay, which means that these are my two factors. X plus 2 times 6x squared minus x minus 15. If I multiply these two guys together, I get this function under here. If I multiply these two things together, the divisor and the quotient, okay, these this times this gives me this. All right, but we need to find the zeros. So I'm going to take this, set it equal to 0. X plus 2 is completely factored. I can't do anything with that. We have to see, can I break this down even more? So since there's a 6 out in front, okay, I can't use AM, so I have to go to AC and multiply 6 times negative 15, which is 6 times negative 15. Oh, 6 times negative 15 is negative 90. All right, so if I do AC, the A term times the C term is negative 90. So I have to figure out, are there any two factors that multiply together to get negative 90? And when I add them together, I get negative 1, because there's a little imaginary negative 1 here. Remember the trick on the calculator? if I go to y equals, and I do negative 90 divided by x, and look at my table, I can scroll through and see, okay, and add these factors together until I get one of them that adds up to negative 1. All right, let's see here. Oh, how about, well, if I add this together, I get, oh, negative 1. There it is, positive 9 and negative 10. Which means I'm breaking this negative 1x into 6x squared. What was it? Plus 9x minus 10x minus 15. Okay. I can do that because if I were to combine like terms here, I get negative 1x. All right, now we're factored by grouping. Greatest common factor between 6x squared and 9x, I think, is 3x. Which would, if I divided 3x out, I get 2x plus 3, right? Greatest common factor here looks like it would be a negative 5, which would leave me with 2x plus 3. That's great. Great news. All right. So now remember, these two guys go together. 3x minus 5. Ugh. And these two guys go together. 2x plus 3. Don't forget about our original 0, or our original factor that we divided by. Okay. And if I were to multiply this times this, excuse me, I would get my original function. Okay? So this is the completely factored form of this. But I'm not done. I have to figure out what all the zeros are. So now I'm going to take each factor, set each factor equal to 0, x plus 2 equals 0, 3x minus 5 equals 0, 2x plus 3 equals 0. All right. So x equals negative 2. If I were to add 5, divide by 3, I would get x equals 5/3. And then I would subtract 3 and divide by 2, so I get x equals negative 3/2. All right. So here's my 3 zeros. I should have done this up here too. I shouldn't just leave my answer like that. I would want to give it in like a set form, okay? And I would just put them in chronological order, negative 1, negative 1/2, and 4. So I start with the smallest, negative 1, negative 1/2, 4. And that's how I should leave my answer. Same thing down here. These are all my zeros. Okay. Put them in numerical order, negative 2, negative 3/2, 5/3. All right, and that's how you do that. Okie dokie. Any questions? Going once, going twice, moving on. All right, we got a couple more. Oh, these are different. Sweet. Given m of x equals x to the third plus bx squared, minus 11x minus 3. And given that negative 1 is a 0, determine the value of b. So they want us to figure out, there's some number here that goes in front of the x squared. There's some coefficient. And I have to figure out what is that coefficient of that function. And the only information I really have is that negative 1 is a 0. What does that mean? That means if I take negative 1 and I plug it into the m function for x, what do I get? I get 0. When x is negative 1, my output would be 0. Well, that's great. I have an x value, I have a y coordinate, an x coordinate and a y coordinate. If I plug in negative 1 for x here, for x here and for x here, it should spit out a 0. If I plug in -1 into the function, so -1 to the third power plus b times -1 squared minus 11 times -1 minus 3, what do I get? If I plug in -1, that should give me a 0 because -1 is a 0. So I'm going to set that equal to 0. We need to solve for b. Okay, that's what the question's asking for us. They want to know what coefficient goes in front of the x squared. All right, so now I just do some order of operations. I'm going to do these exponents first. -1 to the third power is -1 plus -1 squared. -1 squared is +1, remember? Okay, and +1 times b is just 1b, or b. All right. -11 times -1, since I'm done with the exponents, I can multiply now. -11 times -1 is +11, minus 3 equals 0. And now I'm just going to combine my like terms. -1 plus 11 minus 3. That should be 11 minus 3 is 8, minus another 1 is 7. So I think I'm just left with b plus 7 equals 0, which means b equals -7. Am I done? Well, yeah, I'm done. It says find the value of b. Here's b. It's -7. Donezo. All right. 2 more, guys. Hang in there. Given Regents question. This one's highlighted. Given s of x is x to the third minus 9x squared minus x plus d, and s of 1 equals -6, determine the value of d. So we have to figure out what constant is this out here. All right, using only this information, that if I plug in 1 into this function for x, what do I get? Well, they're telling me I get -6. If I plug in a 1 here, here, and here, I get -6. So let's do that. Let's plug in 1 for x. So 1 to the third minus 9 times 1 squared minus 1 plus d equals what? When I plug in 1, what do I get? I get -6, so equals -6. All right. Now we'll just do some order of operations. 1 to the third is 1. 1 squared is 1 times -9 is -9 minus 1 plus d equals -6. All right. Combine your like terms. 1 minus 9 minus 1. That should just be 9, right? No, minus 9, -9. So I have -9 plus d equals -6. And I'm trying to solve for d, so plus 9, and d should equal 3. Am I done? Yeah, I'm done. It says find the value of d. Here it is. Finito. All right, the last one, and this one is a doozy. Lots of work for this one, so try and stay with me. There's a lot of steps. We have to really kind of dissect what this question is actually asking. Given, I have a function h of x, 6x to the third plus bx squared minus 52x plus 15. They're giving me that when I plug in 2, I get 35. When I plug in -5, I get 0. Algebraically determine all of the zeros for h of x. All right. Well, first things first, I don't really know what function h of x is yet. I know one of the terms is 6x to the third. I know one of the terms is -52x. I know one of the terms is plus 15. But I don't really know what this term is. There's some number in front of the x squared, but I don't know what it is. So that's the first step. I have to figure out what coefficient is in front of the x squared. Okay, so I could use a couple of different things here. All right, I'm going to use this piece of information because this function's probably going to have more than one zero. Okay, so I'm going to use this piece of information here. This says when I plug in 2 in for x, okay, I get 35. So let's plug in a 2 for x and set that equal to 35. And then we could solve for b. So 6 times 2 to the third power plus b times 2 to the second power minus 52 times 2 plus 15. And this told me over here when I plug in 2 I get 35, so I'm going to set that equal to 35. Alright, order of operations. 2 to the third is 8. 8 times 6 is 48. Plus 2 squared is 4. 4 times b is 4b. Negative 52 times 2 is negative 104. Plus 15 equals 35. Alright, I'm going to combine my like terms. 48 minus 104 plus 15. When I combine like terms, I get negative 41. So I have 4b minus 41 equals 35. If I add 41 to both sides, I get 76. 4b equals 76. And when I divide by 4, I get b equals 76 divided by 4 is 19. Alright, so now I know the function, okay? Because I know we just solved for the b part. I know that the coefficient for x squared is 19. So now I know the function, which is good, okay? I know that h of x is 6x to the third plus 19x squared minus 52x plus 15. I'm just going to write that here just to remind ourselves. H of x actually equals 6x to the third plus 19x squared minus 52x plus 15. That's the actual function. All right. Let's jump over to this piece of information. H of negative 5 equals 0. That means when I plug in negative 5 into the function, I get 0. If I plugged in negative 5 here, I get a 0. It also means what would be a factor of this function? If h of negative 5 is 0, remember the opposite, okay, would be the factor. If I were to work backwards. That means that x plus 5 is one of the factors of this function. Okay. What's another factor of this function? What can I multiply x plus 5 by in order to get this? Well, in order to figure that out, I have to divide h of x by the factor that I know, x plus 5. Okay, so I'm going to divide this function by this factor to figure out what's the other factor. So x plus 5. Okay, we're going to divide that into 6x to the third plus 19x squared minus 52x plus 15. Alright. So what times x is going to give me 6x to the third? I think 6x squared. And 6x squared times 5 would be 30x squared, right? And I'm going to subtract that out, the whole thing. These will cancel, that's good. 19 minus 30, what is that, negative 11? Bring down minus 52x. All right, now what times x is going to give me negative 11x squared? How about negative 11x? This times this is this. Negative 11x times 5 is negative 55x. And remember, I'm subtracting the entire thing. Negative 11x squared plus 11x squared cancels. Negative 52x plus 55x is 3x. Bring down our last term. Okay, what times x is going to give me 3x? That would be 3. So I get 3x, and then 3 times 5 is 15. This is good, because now when I subtract, I get 0, which means there's no remainder. Now, what does this mean? This means if I take x plus 5, and I multiply it by 6x squared minus 11x plus 3, I get the function 6x to the third plus 19x squared minus 52x plus 15. Okay, these are the factors. We need to find the zeros, so I take the factors, I set them equal to 0. I just have to figure out, is this completely factored? Well, probably not, but let's just check. Okay, there's a 6 out in front, so I can't just go to AM, I gotta do AC. 6 times 3 is, my AC would be, 8 times C is 18. I gotta figure out, are there any factors of 18 multiply to 18 and add up to negative 11? No, not that one. How about, oh, I found it. I figured it out. What two numbers multiply to positive 18 but add up to negative 11? Anyone get it yet? How about negative 9 and negative 2? Alright. If I combine like terms, I get negative 11. That's good. Alright, now factor by grouping. Look for GCFs in the two groups. My GCF here is a 3x. I factor that out. I get 2x minus 3. I want to factor out, what can I factor out of here so that I get 2x minus 3? I think just negative 1. Alright, remember these two guys go together. Remember, whatever the repeating factor is one of the factors. And don't forget about this x plus 5. That is also one of the factors. So here's the completely factored form of our original function. I need to find the zeros, so I take each factor and set each factor equal to 0. So what are my zeros? X equals negative 5. We kind of knew that already from this. Negative 5 equal h of negative 5 equals 0. For this one, I would add 1 and divide by 3. So I get x equals positive 1/3. Over here, I would add 3 and divide by 2. So I get x equals 3/2. All right, here's my 3 zeros. I'm going to put that in set notation. So my solution, or my solutions to this function are negative 5, comma, 1/3 would come next, followed by 3/2. All right. Yeah, that was a lot of work for one problem. I probably wouldn't have finished that in class, to be honest. All right, guys. So this is the last lesson for Unit 10. All right. I hope you enjoyed. I promised a couple of you that I would show you my dogs. Eleanor. Sadie. Eleanor. They don't want any part of me. Come here. Here's Sadie Jean, the one-eyed lady. Say hi, Sadie Jean. Hi. Come on, good girl. Yeah. Sadie, the one-eyed lady. And Eleanor, come here. Eleanor's shy. She doesn't want to come here. Maybe I'll show her next time. I hope you guys are doing good. Stay healthy. Wash your hands. Give a little scritch to the dog. And I hope you guys have a nice week. I'll talk to you soon.